Now, in this question, you are supposed to interact with the stage control to see the different rings. So, there is a ring that represents n, and then there is the circumference of a specific circle. All right. So, what happens in our case? When there is the first ring, the circumference that we are being told about is 48 pi centimeters. All right. In another case, the circumference is 60 pi, and the diameter is, of course, 60 centimeters. And as we move down, the ring n, the value of n as it increases, the circumference of the circle C increases. So initially the diameter was of 48. So whatever the diameter was, the same thing added to pi was the circumference. Alright? This is something that we are being told. So there is an increase of positive 12 in our case. The first part says, write down the missing values in the table up to ring 6. So as far as the missing values is concerned, it's not something difficult for us, right? We can see that this value is supposed to be 96 pi, and this value is supposed to be 108 pi. As in all cases, the values of the circumference are increasing by a value of 12 pi. Alright, so that was the first part.
All right.
Then we are told, describe in words a pattern you see in the table for the circumference C. So always remember that the first idea should always be term to term. So compare this with this. A comparison should be done. So we can see as the ring number n increases by 1, the circumference increases by 12 pi centimeter each time. Okay, be very careful. A mistake that most students make is that um, the mistake that they do basically is that they don't look at the sign being represented here. Okay, so usually what happens is that you are being told with reference to n of a stage, right? As of yet, we've always seen stage. Sometimes the word is changed. Sometimes ring is mentioned. Like in this case, the student might do a mistake, and that is that here they might write stage. So, for example, they might say as the stage number increases by 1. Now, this has a chance of probably, uh, decreasing your marks, or you might end up losing your marks. So, a student has to be very careful in this regard. All right?
Yeah.
Okay. Let's continue then. Write this down first. Then we are being told, write down a general rule for C in terms of n. Okay, so if you're talking about a common difference, the common difference is of 12 pi. Okay, so the equation is A plus n minus 1 multiplied by D. Alright, So the principal term A, the first term, is 48 pi plus n minus 1 multiplied by the common difference. The common difference is of 12 pi. So we have 48 pi plus 12 pi n minus 12 pi. So 12 pi n remains as it is, plus 36 pi remains as our answer. Alright, write this down. After that, we are being told we have to verify our general rule for part C. So our general rule basically was 12 pi n plus 36 pi, right? That was our real general rule for C in terms of L, right? That was our general rule. Okay, so we can say in order to verify this value, we can do it since it's a 3 mark question. Let's do it for three values. Let's do it for n equals to 2. So you have 12 pi times 2 plus 36 pi. That gives us 24 pi plus 36 pi, which gives us an answer of 60 pi. And then let's do it for another value, which is n equals to 4. So that is 12 pi times 3 plus 36 pi, which equals to 72 pi. And our next two values were 96 pi and 108 pi. So this becomes n equals to 6, for instance. So we have 12 pi times 6 plus 36 pi. So that is 72 pi plus 36 pi, which is 108. So these three are going to be the correct answers. Generally speaking, you can select any of them, but ideally you should pick this one.
I wrote it down.
That's good. Then what do we have? Part E says, for ring 1, show that the arc length of a pink tile is 3 pi centimeters. Okay. Um, for a pink tile. So in ring 1, we have 12 blue tiles and 6 pink tiles, right?
Yes.
So each blue tile has an arc length of 5 over 2 pi. First things first, let's calculate the total arc length of all blue tiles. So the total arc length for all blue tiles or blue tiles is going to be 5 pi over 2 multiplied by 12. Okay. So if we do that, 5 pi over 2 multiplied by 12. I think 12 and 2 cancels out, so that gives us 6. So 5 pi times 6 becomes 30 pi. Agreed? Now, this 30 pi is the arc length for the blue tiles. The total circumference, the total circumference was basically 48 pi. So from 48 pi, if we remove 30 pi, we get 18 pi. And 18 pi is basically the arc length of the pink tiles. But how many pink tiles do we have? We have 1, 2, 3, 4, 5, and 6. Right? So we have 6 of them. So if we were to divide 18 pi by 6, we would get an answer of 3 pi. And that is how we would prove it that this belongs to the arc length of a pink tile is going to be of 3 pi centimeters. Alright? I hope that's clear.
Yep.
Great. Write this information down so that we can move forward. Okay. Investigate the values in the table to find a relationship between the arc length of the pink tile in terms of in your answers you should predict more values. Okay. And record these in the table. So we know first things first, this is supposed to be 96 pi and this is supposed to be 108 pi. And we also know that this value is going to be 30 and this value is going to be 36. Can you guess the pattern that is being followed in this case? Think about it. What can you notice? Yes, any ideas?
Not so sure.
Okay, let me write this instead of 3, let me write this as 3 over 1. Now have a look. Try to decode the part. What's happening to the numerator and what's happening to the denominator?
The numerator is increasing by 2 each time. They're odd
Yep,
numbers.
exactly.
And the
Yes,
denominator is increasing by 1.
exactly. Good job. So this becomes 11 over 5 and the next one becomes 13 over 6. That makes sense, right?
Yeah.
That's great. Because I'm sure that the question is around this value. So if someone was not able to find the pattern being followed here, it's going to be difficult for them to solve the question. Okay, yeah. Describe in words two patterns for column L. All right. How to describe a pattern for column L? First things first, I can say that there is a fraction numerator and denominator pattern. What does that mean? So, for example, whatever the fraction it has a numerator that increases by 2 each stage and a denominator being equal to the ring number. I can write this as well. So, wait a second. Where is my cursor here? Yeah, the pattern is numerator increases by 2 each stage or each ring or each n value where denominator is equal to n. Write this thing down first.
I wrote that down.
Okay, think of another pattern that you can see. Can you see another pattern?
No, I'm not sure.
All right, have a look. The numerical value, if you were to use a calculator, 3 over 1 is exactly 3, 5 over 2 is 2.5, 7 over 3 is roughly 2.33334, 9 over 4 is 2.25, 11 over 5 is 2.2 exactly, and 13 over 6 is 2.18. Now, can you see a pattern here? Now you should guess it.
I'm still not sure.
Cannot we say that the values are approaching 2? This is also a pattern, right?
Yeah.
We can say another thing of the pattern. I'll have to erase this because I don't have enough space. Can I increase the page after this? Wait. No, apparently I cannot. That's sad. So we can say as n value is approached or as n value increases, 2 is approached. That's fine. That's going to work. Make sense?
Yeah.
That's good. Write it down.
I wrote that down.
All right. Let's move forward. Then the next part might be Find a general rule for L in terms of N. L in terms of N. Okay. So, in order to find a general rule for L only in terms of N, we can say one thing for sure. Look, whatever the numerator is and whatever the denominator it is, okay? If we add 2 to the numerator, sorry, whatever the denominator is, if we add 2 to it, we get the numerator. Am I right? So, for
Yeah.
example, if here the denominator is 1, if we add 2 to it, we get 2. No, that's not always the case. Wait. We're not adding 2. Okay, I know what we're doing. We are multiplying that number with 2 and then adding 1. You see, this is a very complex thing to understand. What's 5 times 2? It's 10. But when we add 10 to it, we get 11. What's 4 times 2? 8. We add 1 to it, we get 9. So what are we doing first? We are essentially, if there is a number of denominator, we are multiplying it with 2 and then adding 1 to it to get the numerator. Alright? So instead of writing this as 2d plus 1, let me write this as 2n plus 1 over n, or whatever that number is. We multiply that by 2 and then add 1 to it, or and after that we just add a pi because our final answer is in case of a pi. So that is going to be our general rule. Make sense?
Yeah.
Okay. For testing our general rule, it can be done pretty simple. Let's say the value of n is, let's suppose it is 2. So 2 multiplied by 2 plus 1 over 2. 5 over 2, that is multiplied by pi and we get our answer. So that's pretty straightforward. And the same thing needs to be done for verification. Do these parts and tell me once you're done so that we move to justification, alright? In the justification part, we need to understand a thing. Let's try to do. Now, when it comes to justification, let's try to understand a few things. First things first, the circumference has been given by the formula 12n pi plus 36 pi, right? And in order to find the value for the circumference of the remaining uh, length for the pink tiles, for the blue tiles we know that it was given by the formula of 12 multiplied by 5 over 2 pi. So that gives us an answer of 30 pi. For the pink tiles, we know that we applied the formula of 12 pi n plus 36 pi minus 30 pi, and that gave us an answer of 12 pi n plus 6 pi. So essentially, we take 6 pi as common, and within the bracket we have 2 pi n. Now, in order to solve for this, wait a second. How many pink tiles did we have, essentially speaking? We had 6 pink tiles, right? and the arc length of a single pink tile was given by the formula of 2n plus 1 over n. So the idea is that whatever value you have for each and every ring, if we multiply it by 2 and we add a 1 to it by the and then divided by the denominator, which represents the same thing as n, we will find the right answer. All right.